Let's start section 1.1. We're going to solve linear equations. This is the first section in the course for college algebra. And I have a couple examples written out, and we should get right into them. In example number 1a, we want to solve the equation 9x plus 11 is equal to 7x plus 1. If you think you already know how to solve this equation, you might want to pause the video and try to do the problem for yourself. The goal here is to isolate the variable x on one side of the equation and move everything else to the other side of the equation. And so the way we're going to do that is we're going to subtract 7x from both sides. And when we do that, the 7x minus 7x on the right side cancels, and we're left with, on the left side, we're left with 2x, that's 9x minus 7x. We still have the 11, and then on the right side, all we have is 1. So that looks good. Now we have x only on the left side of the equation. Let's take the constant 11 and let's move that term over to the other side of the equal sign. So we're going to do that the same way we did with the 7x. In this case, we're going to subtract 11 from both sides. 11 minus 11 cancels, and we're left with 2x on the left, and 1 minus 11 is negative 10 on the right. There's one more step to isolate x. We need to do the opposite operation of this multiplication here. 2 times x means we need to divide by 2 on both sides, and the 2's cancel, and we're left with x equals negative 5. And that's our answer. Notice we've tried to be pretty neat here. We've got our equal signs lined up as we work down the page. Notice we worked down the page as we went through the equation. So our final answer is x equals negative 5. There's another way to write that, which is with set notation, which is this curly brace. And you can put the negative 5 inside the braces, and that's a great way to write your answer as well. And then there's one more thing that we might like to do in this problem, and that would be to check your answer. And so if we're going to check, then we're going to take that answer, negative 5, and we're going to plug it back in for x in the original equation, and we're going to see if it makes a true statement. So we've got 9 times x. Instead of x, this time we'll write 9 times negative 5 plus 11. And then on the other side of the equal sign, we have 7 times x, 7 times negative 5 plus 1. And this is a question right now where we want to verify that this really is true. So we have, so what we're going to do is we're going to simplify the expression on the left side of the equal sign, and we're going to simplify the expression on the right side, and we're going to see if we get the same thing both ways. On the left side, negative 45 plus 11 gives negative 34. And on the right side, negative 35 plus 1 also gives us negative 34. And so it worked. So we got the correct answer. Notice when we were checking, we just worked through the expression on the left and then worked through the expression on the right. We did not take terms and move them from one side of the equation to the other like we did when we were solving the equation. Okay. So that's the first problem. Let's go on and work a couple more. They should get a little more complicated as we go along. So let's have a new problem here. Again, if you think you know how to work it, then you should pause the video and try it for yourself. Okay, so what we have here is a problem that needs the distributive property. And so on the left-hand side, we're going to distribute the 4 to each term inside the parentheses. We're going to multiply 4 times negative 2x and get negative 8x. And 4 times 1 is 4. And then on the other side, this is maybe the hardest part of the problem, or where I see students make the most mistakes, is with this minus sign. So what you need to remember is that there's a 1 that's understood between the minus sign and the open parentheses. And so we need to think about this as distributing a negative 1 to each term inside the parentheses. Or another way to say that is just to distribute the minus to each term inside the parentheses. But it's not a 6. And we're not distributing the 6. The 6 is going to be added on to this second part. Or a better way to say it would be to say the second part gets subtracted from 6. So the 6 just comes down. And then minus 1 times 2x is minus 2x. And minus 1 times minus 4 is plus 4. Okay, so you really want to be careful with that step right there. And then we can go ahead and move terms from one side of the equation to the other. And we can also combine like terms that are already on the same side of the equation. So in particular, I'm looking at the 6 here, this constant, and this constant 4. And I'm saying that I can add 6 plus 4 and get 10. And so let's just take our time and just write that much. And then we'll go on to the next step in just a moment. So we combine like terms on the right, and we've got this equation here. This looks very similar to the problem we did in number 1a, in the first example, 1a. So let's go ahead and add 2x to both sides to get the x terms together on the left. And we'll have negative 6x plus 4 equals 10. And then let's subtract 4 on both sides to get the constants together on the right. And we'll have negative 6x equals positive 6. The last step, divide by negative 6. And we have x is equal to negative 1. Again, we might want to write that in set notation. Okay, and then let's go ahead and check our answer. We won't check, we're going to solve a lot of equations this semester. We won't check our answer every time, but here on the first day of the course, we probably ought to try to make some good habits. So let's go ahead and plug that negative 1 in and see if it really is true. So let's go ahead and rewrite the original equation. 4 times negative 2, and then when we get to the x, we're just going to replace that with a negative 1, and then plus 1. And then that's supposed to be equal to 6 minus parentheses 2 times the negative 1 minus 4. And it's a question, and we're going to simplify on the left side and see what we get, and then we'll simplify on the right after that. So we need to follow order of operations. Inside the big parentheses here, we have some smaller parentheses that say negative 1 times negative 2, which is positive 2, and then plus 1 gets multiplied by 4. 2 plus 1 is 3 times 4, or 12. On the other side, the first thing we need to do is multiply 2 times negative 1 and get negative 2. Minus 4 just comes down, and then in front, 6 minus that. And then inside the parentheses, we'll have minus 2 minus 4 gives you minus 6. And then remember, if we subtract a negative, then that's the same thing as adding. And so what we really have here is 6 plus 6, which is in fact 12, and we got the answer correct. Okay, so in this second example, the new idea was the distributive property here to deal with parentheses. One more example and in this first video, and now the new idea is fractions. So have a look at this new equation. If you think you know how to solve it, pause the video and give it a try. There's more than one way to solve an equation that has fractions in it. The way that I'd like to do it is I would like to clear the fractions in the first step. I would like to clear the fractions in the first step. You could skip this, and you could just combine the x terms on one side and the constants on the other, and do it and treat the fractions like we treated the previous the numbers in the previous examples. But this method here, clearing the fractions in the first step, is really nice because it's going to reinforce some ideas that will be necessary later in the course. So what I'm saying here is that for now we have a choice not to clear the fractions, but in a few more sections we will absolutely have to clear fractions. So it's good to practice now with something that's a little easier before we get to something that's a little bit harder. Okay, how do we clear the fractions? We multiply both sides of the equation by the least common denominator. And so we need the least common denominator of 4, 5, and 2. Remember, least common denominator is the least common multiple of the denominators. So let's just show a little extra work here, and if you already know the answer, bear with me here. When we say we want the least common denominator, we need to think of multiples of 4, which would be 4, 8, 12, 16, 20, and so on. And we also need to think of multiples of 5, which would be 5, 10, 15, 20, and so on. And we also need to think of multiples of 2, which would be 2, 4, 6, 8, and so on. And so when we say what's the least common denominator, we want the first number, the smallest number that appears in all 3 of these lists. Can you see what it is? It's 20. It's 20. Okay, so what we're going to do is we're going to come back to the equation, and we're ready to start our work now. We're going to multiply by 20. This is a good way to show the work. You can put parentheses around the entire equation, just like I've just done, or it might be nice to put an extra set of parentheses, to have parentheses around both sides of the equation, so it feels more balanced, right? We're trying to do the same thing to both sides of the equation, so multiply by 20 on both sides. And so now what you see is on the left side is you have 20 times each of the terms inside these parentheses. That's the distributive property again. And so you could come out to the side and you could do 20 times 7 over 4. Again, if you already know the answer, great. If not, if you're not sure, then bear with me and let's run through a little bit of multiplication of fractions. So what we're going to do is we're going to multiply numerator times numerator and denominator times denominator, and then we also need to simplify. And that'll be easier if we simplify first and then multiply. So maybe seems a little bit backward, but the first step should be to cancel a common factor of 4 in the denominator here and in the numerator here. And then, of course, 4 goes into 4 one time, and 4 goes into 20 5 times. So now when we multiply across, we get 5 times 7, which is 35. And we get 1 times 1, which is 1. And so we have 35. Okay. Let's try to go through these just a little bit quicker. Let's do 20 times 1/5 x. And you can see that 5 goes into 20 4 times. And so you have 4 times 1 is 4 times x. And then you have 20 times -3/2. And 2 goes into 20 10 times. And 10 times -3 is -30. So what we have here on the left side of the equation is 35 plus 4x minus 30. And that's equal to, on the right hand side, we just need to multiply 20 times 4/5 x. So we're going to do it the same way that we did the left hand side. We're going to say 5 goes into 20 4 times, and then that 4 gets multiplied by 4 times x. And so we have 16x. Fractions are hard. Be sure to practice, and we'll get better at them as we go along through the semester. Okay, we need to go ahead and finish solving this equation. This looks a lot like what we were doing in the previous examples now, so maybe it shouldn't be too bad. Let's see here. Could we just take the like terms on the left side, that's 35 minus 30, and call that 5. Let's see, where I'll write it right down here. And then could we, at the same time, could we also do a minus 4x on both sides? And we'll have 12x. And notice this time I got the x's together on the right hand side of the equation. Usually we do it on the left. Why did I put the x over on the right? Just to save a step, just to go one step quicker through the problem. So the problem's long enough already. Let's not make it any longer. You can leave the x over there on the right side, or if you want, you can just switch the two sides. And so I guess I'll just do that right now. If 5 is equal to 12x, then 12x is equal to 5. And I can go ahead and divide by 12. And my answer now is 5/12. I can write that as x equals 5/12 in the box, or I can put that into set notation. It would be great if you took that answer and you plugged it back into the original equation to check that it really is correct. I won't do that right now, just in the interest of time, but I encourage you to do that, and that would be a good way to practice the multiplying and adding fractions a little bit more.